See the next chapter, chapter 5, arithmetic progression. We are in exercise 5.1. Let's solve the first question, question 511. We have been given 4 different scenarios, and in each of the following situations, does the list of involve arithmetic progression. Remember, arithmetic progression is when the subsequent terms having constant uniform difference, which is the common difference, and we have to explain. We can create like first couple of terms, identify the pattern, how the numbers are evolving, and with that we can make our own conclusion. So let's begin. The first question is the taxi fare after each kilometer, when the fare is 15 rupees for the first kilometer and 8 rupees for each additional kilometer. So if I use the taxi service for just 1 kilometer, I will have to pay 15 rupees. But for each additional kilometer, I will have to pay 8 rupees extra. So that means if I use the taxi service for 2 kilometers, I will have to pay 15 plus 8 equal to 23 rupees. And with that logic, I can expand this further. If I use the taxi service for 3 kilometers, I will have to pay plus 8 extra. So altogether, I will have to pay 31 rupees. And eventually, if I use it for 4 kilometers, I will have to pay 39 rupees. And then this can go on forever. Remember, here, the difference between the two consecutive terms is plus 8, which is constant. Even though the first term is 15, which has got nothing to do with this one, the condition is that the difference between the two successive terms has to be uniform. So we can pretty much see here the difference between any two successive terms is plus 8, and that represents the additional amount which are paying for extra 1 kilometer. So yes, this represents an arithmetic progression. Second one, the amount of air present in a cylinder when a vacuum pump removes 1/4 of the air remaining in the cylinder at a time. So let's assume that we have initial air as x. Now 1/4 of this air will be removed in unit time. So if 1/4 is removed, that means 3/4 of the air will be remaining. So 1/4 is removed, so 3/4 of that will be 3/4 of the original amount will be retained. Now, this is where the difference actually begins. The air removed is 1/4. The air retained or kept is 3/4 of the existing instantaneous amount, not the original amount. So if you continue this operation of vacuum pump, 1/4 of this 3/4 x will be removed. Or in other words, 3/4 of 3/4 x will be retained. So in that case, 1/4 is removed, 3/4 of 3/4 x will be retained. So eventually, after 2 units have elapsed, the air remaining will be 3/4 square of x. And with this logic, 3/4 of 3/4 square x will be retained. So as you can see, now the power is increasing. If you take the difference of any two successive terms, that will not be constant. In fact, here the ratio is constant. That's not an arithmetic progression. When you study further, you will realize that this is called geometric progression, where the ratio is supposed to be uniform. But that's a totally separate progression that has got nothing to do with arithmetic progression. So for the time being, just remember, if the difference is constant, then only it is arithmetic progression. If the ratio is constant, that's geometric progression. That's totally separate, not at all related to current topic. So this is not an arithmetic progression. The third one, the cost of digging a well after every meter of digging, when it costs 150 rupees for the first one, and it rises by 50 rupees for each subsequent meter. So if I dig the well for 1 meter only, I will have to spend 150 rupees. Now, if I dig it 1 meter further, my expenses increase by 50 rupees, and my second meter of digging cost me 200 rupees. With this logic, my third meter of digging will be 250 rupees, and so on. As you can see that each subsequent meter of digging of this well is increasing my cost by 50 rupees uniformly, and the difference between two successive consecutive terms is always constant. So yes, this is an arithmetic progression. The last one is related to compound interest, and that's a keyword. You have 10,000 rupees in the bank, and the money is uh, accumulating compound interest 8% per annum. If you don't remember the formula for compound interest, it is principal P times 1 plus interest rate by 100 raised to n. We'll see that in a minute. So originally, if you have 10,000 rupees, after 1 year, the amount, which is including principal and interest, will become 10,000 times 1.08. From where I'm getting this 1.08? 1 plus this 8%, which is 8 by 100. So 1 plus 8 by 100 is actually 1.08. Technically, there is a raised to 1 here, but even if you don't write it, it's okay. For the first year, this will be the amount. Now, in the second year, this will become the previous amount, 10,000, then 1.08 raised to 2 because it's a second year. And this will keep on going forever. 10,000, 1.08 raised to 3, and so on. So if you take the difference between these two numbers, that's not constant. Here also there is a ratio, it's constant. But again, that's geometric series. That has got nothing to do with arithmetic progression. This is geometric progression. So again, fourth one is also not an arithmetic progression.